We're not done yet. Got the engine in. The rebuild is done. I'm just waiting for some carburetor parts, which should be here any day. And I've got tires coming too. Got the tubes today, which is nice. But I need the tires more than I need tubes. Okay, where we're at now is we've got some electrical gremlins. We have a suspected floating ground. That's as good as it sounds. It's really not a good thing. But it's an easy fix. So these directionals are not factory. They were added on by the dealer, more than likely. And it's a pretty simple setup. We're going to jump a little bit ahead, but it's necessary in order for us to understand how this all works. I've already rewired all this, and I won't tell you what the outcome is yet, but we'll talk about that later. But I want to talk about how the system actually functions. What does it consist of? How does it work? There's many viewers who don't know this, and I want to try to provide as much information as I can. Turn signals, or directional circuits, work pretty much the same way, regardless of whether it's a small bike like this with a 6-volt electrical system, or if it's a limousine with a 12-volt backbone behind it. It's pretty much the same. Now, modern vehicles have replaced this little flasher with a solid-state component that has no moving parts. This actually is... This technology dates back to like the 1920s. But we'll talk about the flasher in a minute. Let's talk about the wiring. So, coming up to the center, or to the headlamp housing, we have 4 wires coming from each turn signal stock, running off of 2 circuits left and right. So the way I have this one wired up, these green wires, there's one here, and then there's one here. These come out of the, I believe it's the left side, front and rear. And the blue wires are on the right side, front and rear. The blue wires serve as our positive side. The frame is ground. Each turn signal stock is grounded to the frame. And they all kind of convene up here. Now in this video we're going to wire up a special ground just for the front turn signals, because I found that the ground in the handlebars here is quite poor. So we solved that problem with its own ground. Okay, how does this all work? It's pretty simple. You've got a positive leg coming off the ignition switch. Now this is switched, meaning that when the ignition key is off, there is no power coming through here. But as soon as the ignition is turned on, this orange wire is energized. It then sends positive current through this wire into our flasher. And from the flasher it goes to this red wire that goes up into our switch. Now the switch is not grounded. This is all positive up here. And we have 3 wires, 1 going in and 2 coming out, if you want to think of it that way. Those 2 wires coming out go back down into here. And we have, they actually tie off now at this green wire here. It's a green with a white stripe. And then we have a black wire. And the green is our left turn signal output, and the black is our right turn signal output. And as you can see, that goes into our blue wiring and our green wiring respectively. So it comes from the frame, from the battery, to the yes, start over. The positive lead comes from our battery through the ignition switch, through the flasher, into the turn signal indicator switch, then back out. All the switch does is it switches from the output from the green wire or the black wire. If you switch to the green side, the juice is routed out to the left stalks, front and rear, and if you switch to the black, it comes out the right side. And the switch, or the bulbs themselves, will illuminate because they are basically closing the circuit between the frame ground and the green wire. It's pretty simple. How do they flash? Well, this flasher works just like the flasher on your Christmas lights. literally the same technology. You've got two contacts. One of them is meant to open and close, and it does that like this. What it does is it uses a bimetallic contact. It's like a spring, if you will, that when it heats up, it bends away. When it cools down, it closes, or it goes back to its original position. So what's happening here, and it happens about once every second or so, when this whole system is energized, that spring, which is deliberately undersized, so it's designed so that it can only carry so much current before it heats up. So when it starts to heat up, because it's literally being overloaded, it bends away and it breaks the contact, shutting the whole turn signal off on whichever side you've selected. So the flasher is actually on the supply side of our power source, not on the output side. So it's actually it's like a little mini circuit breaker, if you will. And when the lights are on, this little circuit breaker is overloaded. It breaks the circuit, but then it cools off and it closes the circuit because that little bimetallic spring is slowly closing itself up as it cools down. And that is how a directional system works. The only difference is if you have an automobile, you've got a heavier duty flasher that's meant to carry a heavier load before it breaks, and you've got more outputs, 2 more in fact. Some newer flashers actually have a built-in buzzer or an annunciator. This doesn't have any of those things. It's a very basic system. This doesn't even have a light on the dash that tells you the directionals are on. In fact, I may add one. I may actually do that, just because I'd like to have one there. But I'm going to be replacing this flasher, and I'll tell you why at the end of this video. But the one that I put in will have an annunciator on it, so you'll actually hear it beep when the directionals are on. Now you know how turn signals work. Let's proceed with the rewiring. We have a problem called I'm suspecting a floating ground. So let me tell you what's happening. So when I turn my directional on either left or right, the rear flashers come on, but the fronts do not. And I've tried changing the bulbs, and that doesn't seem to affect it. It's really quite bizarre. What I believe the issue to be is the fact that these directionals are bolted to the handlebars, and there really isn't a very good ground to these handlebars. I'm going to change that. But anyway, so what's happening is electricity takes the path of least resistance. So there's less resistance going from here to the rear than there is to the fronts, because the rears are grounded to the frame, directly to the frame. And that is where the bike's main grounding point is. There is no good ground to the handlebars. There's nothing bolted to these handlebars that I can see that would be considered a ground. That's an easy fix. I'm going to take this all back apart, and we're going to add a new ground. I'm going to ground these directly using ring connectors, and that'll take care of that. Problem solved. Yes, no, maybe. But I'm not going to stop there. I'm replacing all the wiring to the directionals. It's piecemealed, it's junk, I want it out. The wiring going to the rear was damaged from the oil. They did not use oil-resistant wiring, and I pulled those out already. Actually, yeah, they should be down here. So, oh yeah, I pulled those wires. Oh, there they are. You can see that these wires are pretty badly damaged from oil exposure, and in some areas, like right over here, the insulation is crumbling and just not good. So that's get it out of here. Okay, and I also want to color code my lighting. You know, I want it to look nice. I want it to look fantastically professional. It doesn't look that way now, so we're going to solve that problem at the same time. So I'm going to start by ripping these off. We're going to replace the wiring in these turn signal stocks with something a little more colorful. Okay, so we got our directionals here, and Yeah, this is like probably 20 gauge, 22 gauge. No, it's about 18 gauge they used. But it's old. It's, you know, it's there's some nicks in the insulation. I don't think I trust it anymore. So let's replace that one, don't we? We lamp out. Okay. So like I said, I think we have a bad ground, and what's happening is the rear bulbs are taking all the juice and the fronts are getting shafted. So now to do this, this is what I had to do. I had to kind of splice off of the original wire right down inside the base because they used a cramp-on button connector terminal there. Made a decision. This is going to be the right side. The right side is going to be green, and the left side is going to be blue. So that'll be easy to figure out. Okay, so I'm going to do the snip snip here, snip snip there. Get rid of the blue. In with the green. And probably going to be easier to... I hate these. I wish I had bought wire on spools, because this stuff really gets unraveled and gets messy really fast. I have a whole bunch of black wire that's in a ball now for that reason. And it's unfortunate, but it happens. I'm going to slip that right in there. Trim off a little bit here. You're going to find that in my wiring jobs, I don't use electrical tape really for anything. I have yet to find a good use for it. Yeah, I find that it doesn't age well, and it really doesn't. It just gets really nasty, and I don't use it. But shrink tubing, on the other hand, is like the best thing since sliced bread. I love shrink tubing. It works so well. So well. So I'm going to do the twisty thing here. And then I'm going to solder it. I'm running a little bit low on leaded solder. I got to get more. I might have to make a trip to my local Radio Shack. And that's not a joke. It is currently January 27th, 28th, 29th, 2018, and there is still a Radio Shack in my area. It is a Renegade Radio Shack. Oh, I almost screwed that up. I need to put this in to the socket first before I do something stupid like that. Hold on. Let's undo this. Yeah, that's got to go right in that socket. Oh, wait a minute. No, I think I can run it through the other way. Yeah, that's right. That's how I did the rear directionals. Because I've already done this job on the rear directionals, and it went pretty smoothly. I'm going to do one on camera, and then I'm going to do the rest off camera. I want to keep this video reasonably short. So let's get some solder on this. It'd be nice if I had a plate underneath it all. You son of a... Stay. There we go. There we go. That's a spicy meatball. Alright, good. No, actually, yeah, that's not a good union. You see, when you have solder on one wire but not the other, it's not a good joint. You want to hit it again. Get more flux in there. There we go. Okay. That's better. So now we're going to fold the connector over like that. We're going to take our shrink tubing and we're going to sleeve the whole shoot and match like that. Then we're going to take some heat. Fire, 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 fire. And we're going to burn, well, not burn, we're going to heat up that shrink tubing. There we go. Voila. Then we're going to cut this to length. I got to figure out how long it needs to be, and then I'll, but I'm going to go, I have way more wire than I need. We can trim this all up when it's assembled. But because these are going into the dash, you know, we can deal with that later, right? Okay, now this gets reassembled back into the lamp socket. We're not done yet. I want my ground wire to come out of here. No, yeah, this is probably not a good ground. And I really just, I don't want to dick around here. I want good grounding. So what I'm going to do is I'm going to actually solder some black wire to that. Hold on. There's that rat's nest of black wire. I just don't trust it. You know what I mean? I don't trust it. I think I want my own ground. So what I'm going to do is I'm going to run some wire through there. Alright, like that. I literally don't trust it, man. I've got grounding issues, so I'm going to make sure I don't have any more grounding issues. Whatever I have to do. Be careful. Sharp edges. You can cut the wire, ruin your day, ruin your life, man. It's bad stuff. Alright, so we're going to make sure there's enough clearance inside this little bucket for that to go into. And we're going to find the securing screw and we're going to throw it in there. There it is. There's that JIS again. This screw has a little dimple on it to indicate such. Okay. Alright, our green wire. There we go. Make sure that bulb still likes to be in there. I got a little too much pressure behind there, but that's all right. It'll ride up with wear. No, yeah, it doesn't want to go in. It doesn't want to go in. It doesn't like it. That's okay. Take it back out. I'm going to reduce that slack a little bit. I gotta find new rubber seals for these lamp housings. The seals are so dry. They're just, it should be pretty easy to get though. Probably a reproduction available too. There we go. That's better. Come on. I don't have all year. There's no room back there for the shrink tubing is what it is. Alright, well. To save time and aggravation, put the bulb into the socket, then make your wire adjustments, and then reassemble it, and you're good. As for this positive lead, or I'm sorry, this ground, I'm going to solder it directly to the lamp socket assembly. And that's how we're going to do it. Twisty, twisty. Solder, solder. That's simple. No, actually, no, it's not going to take it. This metal is coated, so it's not going to work. It's I believe it's plated. So what I'm going to do is cram it under that. I could waste it. How many did I buy? Where are they? I thought I bought some ring connectors. I put them all. If you like it, you can put a ring connector in. Come on, where are those ring connectors? Did I not buy them? I know I hemmed and hawed over that expense, but I wasn't sure how far I went with it. What the hell? I thought I bought some ring connectors, man. I cheated. I didn't put any, I didn't buy the ring connectors, and I know I have some, but I'm saving them for other things. And I'm just going to do this. I'm just going to soak some solder into that little loop I made, so it doesn't come unfrayed. There we go, that's good enough. I just took the loose wire, wrapped it around the screw, and threw some solder in there for moral support. And that's it. That's all she's getting. Sorry. Alright. That's good enough. Good enough for government work. Now, where is my mind? Oh yeah, there we go. Look at that. All done. There's one. One end done. Son. Okay. I also want to take some shrink tubing. So this is going to mate up with the ground wire that I am adding. Or maybe not. Maybe I don't need that. Maybe I'm just being a total... Yeah, I think I am. I'm being... You know what I mean. That's what I'm being. This is not necessary. I'm just going overboard. And, here we go. Okay. Right. Nextly, we're going to do the other one. Same way. Only it'll be blue. So let me zip this up for the rear turn signals that have to be done. Have yet to be done. I want to get this all mangled up. This is what happens when you let those spools get put into a storage bin without being properly tied. That's what happens. Talk to your kids about that. It's not good. It's bad news bears. There's wire everywhere. That's good enough. Okay. Look what I found. I found a short circuit. Yeah. This is right down to wire. You can see just a bit of wire in there, which means that it was shorting out actively. Wow, that's a wonderful how do you do. I decided I'm going to run the ground right up into the headlamp housing. So there was our left and our right, and did some shrink tubing to hide the multicoloredness from the leering eyes of passers-by. So let me go. I'm going to mount these into the. Actually, I'm going to run my ground wire first, and then we'll see how things go. Okay, so here's our new ground wire. Notice I have one for left and one for right. So this is going to serve as the new ground for the front turn signals. And the rear are going to get their own. This way, there is no possibility that there is a bad frame or body ground. No, we're not messing with that anymore. We're going to have a dedicated ground for the directionals exclusively. I can't wait to see it in action. Alright, excuse me. Nextly, I think I'm going to wire up the front turn signals, and then we're going to work on the back. So, stay tuned! Oh, yeah, I'm also going to run a dedicated positive connection that'll feed right into this relay. I'm not, I know, well, I don't have to do that. These are actually usable. I got to find the one that's switched, because I don't want it to be on all the time. So I got to find one that's switched. And I might even throw a fuse in there for good luck, because there were no fuses anywhere. Okay, yeah, I'm losing my mind. There were no fuses. There was nothing. There's no fuse box in this bike. It's all just, yeah. Okay. All right. So at this point, we've got. I made a couple of pigtails and jumpers, and so we've got left, right, left, and right. I'm sorry, front and back, left, front, and back, right. So yeah. Oh wait, no, that's the ground. Here's the ground one. The red ones I used for positive. The blue ones I used for ground. There we go. Yeah, there should be a jumper off of this one, and that's going to go to the rear. So there's going to be another line running to the rear. It's all just a big mess. But anyway, it all makes sense. It should work. At this point, I just need to find a good positive lead for this, and we should be up and running. Okay, so now we can at least test the system. I did some testing here with my multimeter, and I found that this orange lead comes out of the ignition switch, and it is switched. So I want to use that. Here we go. Okay, we still have a red brake light, or yeah, tail lights working, and got our horn. And let's see if the directional works. It works. And that does not. Do you know what that means, folks? Do you know what that means? It means that that bulb is of the wrong wattage, so it's going to take a lot. There it goes. There she goes. Yeah. You can actually almost hear this thing. Now all we got to do is replicate that success on the back, and we're good. Okay, was it worth it? Let's take a look. Let's turn the ignition switch on and hit it. Oh, well, that's a horse of another color. I mean, we have light there. Let's see about the back. I'm not even seeing a glow. What about the other side? What do we got? Yeah, pretty much nothing, but there's definitely a load there. How about the front? Yeah, not much of anything, but there's definitely some kind of a load, and it's something's flickering. So let's talk. Now, I was pretty certain that we had really just a bad ground up here in the front, and again, we wanted to neaten up the wiring anyway, so that all aside, we still have a problem. There's one thing we haven't done. Now, I did actually take this switch apart and I cleaned the contacts. Everything's good. Cleaned them, lubricated it. It moves nice and freely now, like brand new. What's the one component that we haven't touched? And it's pretty obvious. We have done nothing with our flasher. I'm thinking to myself, what are the odds the flasher could have gone bad on a bike with just 3,500 miles on it? What are the odds? Then I got to thinking. When I took that engine apart, I found some serious problems. Problems that should not arise on a bike with 3,500 miles on it. Now let's take a look at this odometer for a second. 4 digits. That means at 9999, that's 9,999 miles, it rolls over to 0. The question is, how many times has it rolled over to 0? You get where I'm going with this. Okay, I'm going to show you how to test your flasher. We're going to test that flasher, and we're going to see if that is causing our problem. I wasn't even thinking. I have never, in my natural born life, seen a flasher go bad. Although I vaguely remember my father replacing one in his 1983 Ford F-150 back in 1996, I guess stranger things have happened. So why don't we position the camera away from the bike to give you a better view of our success or failure. Ready? Set? Okay. I'm going to take a conductive object and I'm going to use it to bridge the two terminals on my two-terminal flasher. That's here and here. Okay, here we go. If we have light, we have a bad flasher. If we have no light, and it's the same problem, then we have a wiring problem or a power supply issue. Just give it a try. I'm going to turn the directional on to left. I'm sorry, that's going to be, yeah, that's left. Here we go. Oh my God. Let's try the right side. Yeah. That's kind of a problem now, isn't it? That's just me hitting the switch. But it looks like we've actually solved or diagnosed our problem. Now this flasher is getting mightily hot, as it's supposed to. It's not meant to power anything for more than a couple seconds at a time. If I hold the screwdriver to it, it does start to warm up a little bit. But guys, I think we found our problem, didn't we? The flasher, for one reason or another, has developed a poor contact between both sides. So there's, like I said earlier, there's a bimetallic switch inside this unit, and that bimetallic switch can fail from a variety of reasons, one of them being overuse or just from aging out. What happens is carbon begins to build up between the contacts, and over time that carbon can cause resistance, which will allow only so much electricity. So it's now acting like a resistor when there's a certain amount of current drawn off of it. And that's where we are. So replacing that flasher should solve our problem completely. I can't open it up. It's a sealed can. I mean, I could crack it open, but I'm not gonna. We're just going to replace it. I should be able to get one for a couple of bucks online. I can't find one locally. It's a 6-volt flasher, and nobody seems to sell these. So we're going to have to order one online. And I'll replace that flasher when I take the front end apart to repaint the headlamp housing. Well, guys, thank you all for your support and your viewership. It's helping me, giving me the encouragement I need to finish this project, as expensive as it's getting. And we'll do a final tally of how much all this stuff costs when I'm done. But right now, I'd prefer not to think about it. Alright guys, on to our next video.